Something that always bothered me as a software engineer, it was installing dependencies for the projects in my local machine or my development machine. Have you passed the challenging on dealing with the version of some program language like Node, Python or whatever? And you probably heard or researched that all of these program languages, they have their own versioning managed, right? Like pyenv for Python or N or NVM for JavaScript or Node.js, whatever. All of the program languages, they kind of solve this problem, having their own version management. But this is so messy. Every language, every program language that you have to install in your machine, you need to deal with also install the management version package for each program language. They behave completely different and behaves in one way. pyenv is a completely different approach, and so on and so forth. If you are working now with a Golang, Kotlin, or whatever, you need to deal with this pain in the ass to manage the version of your program language, or sometimes with your database, if you use like a MySQL, Postgres, MongoDB, whatever. Since the beginning of Vagrant actually, which is a virtualization approach that it's until now used a lot in the cloud computing idea. The software engineers, they had the idea to let's try to encapsulate this messy of the environment in the virtualization way. But Vagrant was actually a little bit like a heavy because used on behalf something like a VMware to virtualize all of the operational system. It was a little bit messy and difficult to deal with that. But after the creation of a container, which is more easy way for the machine to deal with like all of this heavy software, these things turns to be more simple. And the precursor of the container, of course, was Docker. It is still the number one, the more famous tool for containerization. Actually, the idea of containerization, it's not Docker by itself, but instead the idea to use the resources of your host machine, your operational system, to share these resources but in an encapsulated way. This is like the summary. You can research a lot of videos talking more about it in the detail. I'm going to put also the description about it here. But my idea is not give you all of the basics information about it, but instead giving you like a real problem that we face and how we use those tools to solve our problem. Basically, this is the Vagrant idea, virtualization idea, and then the container idea, but they are just things that started to appear to solve our problem of dealing with this version of tools. Can be a program language, can be a database, whatever. It's now heavily used in the production environment, so AWS, all of the clouds that we know, they use it from DigitalOcean to Azure to Google Cloud, so it's pretty normal that while you are doing something on your daily programming, you are using containerization, not necessarily Docker. Like GitHub Actions, you probably use that there is some containers running on behalf of this magic of the actions on GitHub. And it solves very well the problem of production. But I also wanted to solve this in my development environment. You wanted to solve this in your development environment. I always get very bored and messy on my machine if I need to install something on my local machine. I don't like this. I don't like to messy my full machine. That said, I like to make my machine very clean, so no database install, no program language install, except the ones that are already installed in the operational system, like Python for Linux. But even though for coding in Python, I don't use this built-in install. I prefer to have an isolated Python version that I know that the same isolated Python version is the one that is running on production, the one that my coworkers are using. That said, what's my idea here? I'm going to create a series where I will teach you how to set up program language, databases, and so on in your machine and run it for how much as you need. So we will do it from scratch. I'm not going the completely detail of Docker or container. As I said, I will add some documents talking about it, but I will not go in the detail. Instead, I will show to you how to do in practice. Let's get hands dirty a little bit and see in practice how it works. So to start, what is my idea? Let's create one Python container and let's make it running. We will create a container, isolated container with a Python version. We will make it running. We will code in our local machine, our host machine, let's say that, and we will run our code inside of this container. But to run this, we will not like stop the container, run the container again. We will kind of run the container as an isolated little machine, and then we will code in our local machine. And then when we want to evaluate some code, run something, we will just run our code on this container without that much effort. We will do the first setup, which is also simple. Then after that, we will run. And in the next videos, I'm going to show how to do it with PHP, Kotlin, Golang, Scala, Clojure, so on and so forth. So let's go to the code then and let's do it from scratch. I created this simple image that shows to you, like in one side we have here a software engineer, you, me, and we have our host machine. And then in our host machine we have like a lot of projects that we needed to have Node.js in one project, Go in other microservices, Kotlin in other, Clojure, Ruby, databases, so on and so forth. This will not be that problem if those languages they don't change versions, right? But actually they change a lot. For example, let's enter here Node.js versions on Google. We see all of the Node.js releases, the dates when they release, the maintenance, to see Node.js 2018, 22. So then you need to have this like 18. We have, of course, the versions that they named LTS, which is a more long support language. But then there is a lot of versions. And to deal with that, you need to install something like NVM in the case of Node, which is, this language specific a version manager. So you would need to have a version manager for Node. So a version manager, which in this case is NVM. So you would need to install NVM for here. And then you would need to do this for all other program languages. This is like a very tough and crazy and messy. Each one behaves different, as I said, so I don't recommend it. To be honest, I'm very against the version manager of that the program languages provide. This is not their job. They need to be the program languages and that's it. So I recommend instead we do some kind of isolation, encapsulation of this. So there is a lot of ways to do. The more effective one, of course, it's Docker. It's by container. So instead of having this messy, you can have like this in your machine. You have just Docker install and that's it. You encapsulate all the program languages, all of the versions in your containers. For instance, this case of Node, you have a 18 version in one container, you have other version in other container, you have like a 20. And when there is a new version, you just set up a new container. It's very easy to set up and remove. You just remove. You don't need to deal with the dependency tree that this language might require because you will isolate this in your container, right? So this is actually interesting because this concept works the same for virtualization. So our biggest win here, it's not about the container or virtualization, but instead the encapsulation idea
For the machine, it's better to have a container than a virtualization because we are not copying, duplicating everything on top of our operational system. We are kind of reusing it. So yeah, so then given that, let's then do something real here in our machine. Let's open our terminal, and I'm going to increase here my font just to see. So this is my terminal. What I will do, I will enter in one path that I created by containers. There is nothing here. And I will basically, I already install Docker, so I have a Docker running. So if I type Docker PS, I have Docker running. The installation of Docker depends on your operational system, but I recommend you type Docker on Google. You will see how download and install for Windows, Linux, Mac, whatever. So I will not cover this because it's too simple. Uh, and then that's it. I install, it is running, I have it running. That in Mac there is a visual interface. In Linux there is a way that you don't need to, but it's pretty much the same. The commands here in the terminal works the same. So then let's create something that we will run Python in this container. I will create here path named my Python project, something like this. If I tap ls, so I have the the path here, and then I will enter and I will create like a hello.py file, and I will just type hello world, like hello docker, close parentheses, and that's it. This is my Python code in hello.py. And then I will create a file named the Dockerfile. Here it's where Docker starts to play. This is basically a file that I will code my container inside. I will say how my container should works like. There is not that much logic here. It's more like a script that with a snippets saying how this container needs to work. So then I type enter. Then basically what I said I started from Python. So I'm getting from the Python official repository, and then column some specific version. For example, Python 3.9. Where I know that this is a name, I just can type like hub.docker.com. This is a Docker hub, and then I can research here. I want a Python. There is a lot of Python images, but there is the official one. And then I click here on tags. I have all of the available tags. There is this Alpine 3.2. By the way, it's very small images. I will create one video only to run with Alpines, as you can see the sizes. And there is tons of versions with a different kind of operational system, let's say, here. So in our case, we are just taking the official one, 3.9. And then we are creating our working dir, the place where we will have our scripts. So then I type work dir space / I created the path that I wanted to code. So inside of the container, so I recommend you type the same usr src / app, and then type this cmd, which is like a command that when you run this container, it will run. So then just follow me. Also type open double quotes tail, close double quotes, comma, double quotes -f, double quotes, comma, and then open close double quotes / dev / no, and close here. Yeah, and then we have if I type ls, we have our Python code and our Dockerfile. So then I just need to build this Dockerfile. So I will create actually an image based on my Dockerfile, a Python image. You see there is a difference between image and container. We are just create an image first, and then from the image we will create a container. So then I type docker build -t. Then I give a name for my image, for example, Python dash runner. And then dot, because I'm already inside of this path, it will look for Dockerfile. Then I type enter. Then it's going to build the image. It might take a while depending on your internet connection. So then let's just wait a little bit. Right, it finished. So then what you can type now, if you type Docker images, enter, you will see your image, like repository Python runner, tag. We didn't create kind of a tag, we can create image ID, created 13 seconds ago, and the size, this image is very big, 1 gigabyte. So then now what we need to do, we need to run in order to create our container. So we will run and create our container. To do that, we type docker run -d dash dash name, and then we will give a name. In my case, I will give Python dash container. And here it's the moment that we will map this path here with my code inside of that path on the container. So actually, instead of run this, I will do something like this first, pwd, because I want to check this, the full path, because I will copy this. So then let's type again, docker run -d -name space Python dash container -v, and then I will copy all this here. I will paste, and then after I will type column, and I will put that path that was inside the Dockerfile, which is /. This one you can copy me, usr /src /app. And then I will give now, I will get the name by the image that we have, which is Python runner. So then I will type, I will copy, I just copied here the name, and that's it. So I will press enter. It created run and make it this image running. If I type docker ps, I will see that I have, let me clean here my screen, docker ps, I have one image running, so it's created and it's running. So now I can run code, my local machine code there. So I can just type docker exec -it, the name of my container, so Python container space, and then Python, because I'm consider that all of this is to go inside of the container. And then I'm just typing Python and the name of my file, that is hello.py. And then hello Docker. If you see here, if we enter on the Docker, let me show to you, docker exec -it, there is a way to enter there in the container. It's just type docker space exec space it, and then the name of container, Python container space bash, because I want to open the bash. Then I enter on this path inside of there, and if I type ls, you see that I will see the Python there. So it's the same to run here inside of the container. So yeah, pretty much it. This is a simple way to you create, make it running, and don't need to have the Python inside your local machine. The other videos we are going to do with other programming languages, Kotlin, PHP, Go, Clojure, and so on. You can look forward somewhere here and get this video, access this video wherever you want. See you.